In the summer of 2016, Pokémon Go launched and became the fastest mobile app in history to reach 50 million downloads. Within 48 hours, the servers were unreachable across entire continents. People who had downloaded the game couldn't log in. Entire regions stayed offline for days. The game itself worked. Nothing had broken in the traditional sense. The company had run out of room. This is not a rare story. It happened to healthcare.gov on the first day the marketplace opened. It happens to ticket platforms every time a major artist announces a tour. It happens to news sites the moment a story breaks. One of the most common failures in software has nothing to do with bad code or careless engineers. It comes from a mismatch between two things: the capacity of a system and the demand placed on it. Understanding that mismatch, what causes it, why it is so hard to solve with traditional infrastructure, and what cloud computing actually does about it, is what this video is about. Every computer has a ceiling. It has a fixed amount of memory, a fixed number of processor cores, a fixed bandwidth limit. When you run a web application on a server, that server is doing real work every time someone visits. It receives a request, queries a database, processes some logic, and sends a response back. Each of those operations costs something: a fraction of processor time, a slice of memory, a moment of network capacity. When you have 10 visitors at once, the server handles all of it without effort. 1,000 visitors, still manageable. 10,000 visitors arriving in the same 60 seconds, and the server starts falling behind. Requests pile up faster than they can be processed. Response times stretch from milliseconds to seconds. Some requests time out and return errors. At some point, the server stops responding entirely. The server didn't fail. It did exactly what it was designed to do. It ran out of room. Here is where the problem becomes genuinely hard, and it is worth sitting with this for a moment. You cannot provision for a demand you cannot predict. Imagine you run a small restaurant. On a normal Tuesday, you serve 30 customers. You have 10 tables, a small kitchen, 3 staff. It works well. Then a food critic publishes a glowing review on a Friday afternoon, and that Saturday, 200 people show up for breakfast. You cannot seat them. Not because your kitchen is broken or your staff are unprepared. Everything is working exactly as it should. But you have 10 tables. 10 tables was exactly the right number for every day before that Saturday. You had no reason to have 200 chairs sitting in a back room on the off chance you'd need them once. This is the trap that traditional infrastructure put you in. You bought a server, or rented a fixed one, and that server had a capacity that did not change. If you provisioned it for your average traffic, a spike would bring it down. If you provisioned it for your worst-case traffic, you were paying for capacity that sat idle 360 days a year. The only way to get it exactly right was to predict your future with precision, and that is not something anyone can do. So engineers would guess. They would over-provision and pay for headroom they might never need, or under-provision and accept that a sudden spike would take their service down. Neither answer was good. They were two different ways of losing. Cloud computing is at its core an attempt to dissolve that trap entirely. The idea rests on a single insight. If a large number of different services all need variable capacity, and their peaks and troughs don't all line up at the same moment, then a shared pool of resources can serve all of them more efficiently than any one of them could serve itself with dedicated hardware. A cloud provider, Amazon, Google, Microsoft, builds an enormous pool of physical infrastructure. When your service needs more capacity, the provider allocates more from that pool to you in near real time. When your peak subsides, those resources are released back into the pool and made available to someone else. You pay for what you used. The resources flow to where the demand is. This is what scaling means in cloud computing. It is not a setting or a feature you configure once. It is a fundamental behavior. The capacity available to your application adjusts dynamically to match the demand being placed on it. When demand rises, capacity rises with it. When demand falls, capacity falls too. Return to that restaurant for a moment. Now imagine you have an arrangement with a supplier who can deliver tables and chairs within 60 seconds of a phone call, and a staffing agency that can send trained servers on the same timeline. Saturday arrives. 200 people show up. You call, and within a minute, the dining room has room for all of them. By Sunday afternoon, the crowd is gone, the extra tables have been collected, and you are back to 10. You only paid for Saturday. That is what a cloud provider is doing when it scales an application. The tables are virtual machines, containers, compute instances, whatever unit your application runs in. The infrastructure adds them when demand rises, removes them when demand falls. Your application does not need to know or care. It has room. There is a shift underneath this worth naming, because it changes more than the technical picture. Before cloud computing, capacity was a capital decision. You bought hardware, committed to it, and lived with the consequences for years. The mismatch between what you bought and what you needed was something you absorbed in outages when you under-provisioned, in waste when you over-provisioned, often in both. Cloud computing turned capacity into a variable operating cost. You do not buy a ceiling and hope it holds. You pay for what you use, when you use it, and the infrastructure adjusts the ceiling for you. The gap between demand and capacity, the gap that took Pokémon Go offline on its second day, becomes something the system is designed to close automatically, rather than something your team has to predict in advance and hope you got right. Scaling, then, is the mechanism that keeps that gap closed. It is the answer cloud infrastructure gives to the oldest problem in computing. Demand is variable, but resources are not free. The question was always how to match the two without wasting one or being destroyed by the other. What you understand now that you did not before is this: a service going down under load is not usually a technical failure. It is a capacity failure. And capacity, the ability to have exactly as much as you need at exactly the moment you need it, and not a server more, is the thing that cloud scaling is designed to provide. The restaurant can finally conjure tables from nothing. That is the promise.